So what we're going to be talking a bit about today is event sourcing. And almost every event source system that you will find out there is consistent. How many have built an event source system before? How many of you have built an event source system that was eventually consistent? Not for read models. In other words, your event store was eventually consistent. There's a very well-known system out there that is actually event-sourced and distributed and eventually consistent. Maybe you guys have heard of it before. It's called Git. I do hope at least everyone here has used it at some point. It's very odd if you're a developer and have never used it. So we're going to talk about how to build business systems in this way. When most people think about event source systems, largely because of event store, they assume consistency on the right side. And in a vast number of systems, this is not something that we need. We can get around this need of consistency. Now, in a lot of systems, it will make your system simpler to be able to have the single writer coming down to your log. You know that you have perfect ordering. You know that everything's consistent. There's some benefits towards that. But there's also some trade-offs that we're going to discuss. One of the largest trade-offs is availability. How many of you have had a system go down before? There are some people without their hands up. I'm wondering what they work on. So if I were to look inside the logs of Event Store, and by logs, I mean the transactional logs, not the logs that we write out for admins to read. I will have identical logs between all of my nodes. This is how the cluster works. We use log shipping. When you do a write to this node here, the first node, we can see the item removed there. We will move that to the other nodes. And then we require a majority of the nodes to acknowledge that they have received this and have successfully written it to disk. Again, we're coming back to what's known as a quorum of nodes must have written this to disk. So the item removed shows up at the second node. It gets an ACK. We have our quorum reached. We have a majority of our 3 servers at this point. 2 out of 3 is a majority. A very small majority, but a majority. Eventually, all of the nodes will have this because the log is replicated across all of the nodes. Eventually. This is a pure consistent model. I can guarantee you ordering of everything, but you must have a quorum of nodes. You can lose a node, that's totally fine. If we have a 3-node cluster, 1 node can go down. Everything will keep working. If you want 2 nodes to be able to go down, we can run a 5-node cluster. These guarantees will be held for you. But there's some problems with this. The first problem is I must have a quorum. There's some other problems. How many of you have worked with this model before? Well, if I want to actually do a consistent read, I need to do a quorum read, correct? I have 3 nodes. We require a majority to actually do a write. Therefore, in order to do a consistent read, I must do a read from a majority of nodes. Fun, right? How many of you actually do that? I think we can identify people that use Event Store. There are 2 clients that actually do quorum reads. Everybody else just goes, well, it's probably close enough. The chances of it not being there are relatively low. So we'll just hope. To be fair, they're right 99.99% of the time anyway. But there's a bigger problem here. What happens when I become geographically distributed? As an example, I put some nodes in Washington, some nodes in London, and some nodes in Tokyo. Well, then the speed of light becomes a real pain in the ass, doesn't it? So if I want to be geographically distributed, one of the things I tend to have to give up on is consistency. And I shouldn't say we have to give up on it. Very often what we start doing is we start isolating consistency. So data in London is consistent with data in London. It's only not consistent with data in Tokyo. Why? Because it's hard to make it with Tokyo. This is common. And this is one of the main places that we end up having to give up on consistency. We are geographically distributed. I want to be able to have a server sitting in Brazil, another in New York City, and another in Netherlands. The speed of light becomes a problem. There's other ways of modeling this, though. Oh, and I forgot to mention oil rigs. Oil rigs are fun. On an oil rig, the chances of you actually having a fast connection are essentially 0. Enjoy your satellite feed. Oh, a 1500 millisecond ping? That seems legit. This is going to bring us to CAP theorem. CAP theorem basically states that you have consistency, availability, and partition tolerance. You can guarantee any 2 out of 3. Yay. So what it really boils down to is we can have consistency or we can have availability. Pick one. In most systems, you are going to prefer to error towards availability. No? I can get my consistency to a point that I am almost correct most of the time. If I can reach that point, I would prefer to guarantee availability in almost all situations. To be fair, when there's an error in a piece of data that someone's seeing from your system, and it corrects itself 3 seconds later, do you get a phone call? What about when the user can't use the system? Do you get a phone call? So, the main thing we're going to be fighting with is latency in order to provide consistency. Once I have geographically distributed things, I need to coordinate over long distances in order to be able to provide consistency. Almost always, we are going to give up on this idea. It's just not feasible. Latencies become too high. So, once we've started doing this kind of geographic distribution, our only option left is to say, we're going to drop consistency. So, how do you actually deal with an event source system where we've had to drop consistency? Pretty much every single event source system you'll find has a consistent event store. The read models are eventually consistent. They might take a few seconds to update, but the write model is always consistent. And that's what you do all your validation off of with your domain. What happens when that becomes eventually consistent? Well, this could be a bit of a problem, couldn't it? So I send him over a command. He loads up off of his events, gets his current state, and says, my command is now allowed to occur. But he didn't know about the other command that he processed yet. Remember that when we're talking about our domain model, we are using this information in order to pass validations. Not having seen that I turned off her bank account would be a real problem if she's trying to use the ATM card. But we can actually work around this, and we can geographically distribute. So here we have an item removed was added to a single node. It will then get replicated over to the other two. Upon acknowledgement of the first one, we have reached our quorum, correct? So, everything should be good. But we have a problem here. If we are allowing multiple servers to be writing concurrently. And that problem is, what happens when we get this? So server A here was doing item removed. Server B was saying this item is deleted. Now, to be fair, removed and deleted are probably pretty close to each other. What happens here? You guys have used Git, right? What would happen with Git on this? Ah, we have a merge conflict. Crap. By the way, how many people have dealt with like a really large feature that you worked on for 2 or 3 months on a branch and then had to merge? Good times, right? This is the kind of problem that we can run into when we are actually distributed geographically. The further we distribute, the more likely this is to occur. And people like to focus on the amount of time that it takes the packet to go over. That's normally not what causes this. What normally causes this is our connection is going down. Our connection went down for 15 seconds. But this is a real problem that we have to deal with. So what's going to end up happening from here? Well, eventually, that deleted is going to come over to this side, and that item removed is going to go over to that side. In other words, they're both going to be following through, and they're going to go, oh, yeah, I have this thing for you, and you're going to tell me that you have this thing for me. Cool. Except now our logs are in different orders, correct? We have a secondary problem here of, should that item removed be allowed if the deleted occurred? Because they did not know about each other. These are very stereotypical problems we run into in these kinds of systems. So, can we detect this? Can I recognize that this has occurred? Maybe. Well, when we deal streams, we deal with an incrementing sequence associated to the stream that represents this event's position within that stream. So if he did a write and I did a write on a stream with 3 events in it, we would have both written event number 4. So all we'd have to look at is event number 4 for me and event number 4 for him the same thing? If they are the same thing, then obviously we are just replicating back and forth. If they are different things, this is more interesting. So we can determine whether or not these things are actually the same. Now it's important to note that for a large number of events, ordering does not matter. A very large number of events. But we want to get to the point where we can actually handle the ordering here. So what we're going to do is we're going to keep the original stream position as well as the stream position where it currently is. Does this make sense to people? So I've got 2 event stores with stream foo that are replicating back and forth to each other. I want to know when he was the originating writer, what version did he write it as? That may be different than what I have it as. So he wrote it as version 4, I have it as version 5. This is a completely valid thing to occur. Because we're appending, I just had some data that he didn't know about yet. Oddly, it's quite likely that he has them reversed from each other. He got A and then B, I got B and then A. Happens on a regular basis. But once I have the original there, as well as what I have, I can identify that we are possibly in a scenario where this has occurred. Be fair, some other things that could cause it, but once I have those two version numbers, we can easily see here what has actually happened. We can see that deleted and removed are flipped between the two different nodes. No? How hard would this be to write something that's checking to find places where this has occurred? Seriously, would this take you more than like 10 minutes? Like, I'm expecting the numbers to be the same. If they're different, it has occurred. It's an if statement. I hear most languages support them. Not really. If you want to have some fun, try using a language that doesn't have an if statement. So now I can detect that these things have happened. These should happen rarely. I could notify somebody of this, correct? As an example, as I'm going through doing my writing, if I see that this situation has happened, I write a $ conflict detected event pointing to the stream and the two events, and I say two events here, it could be n events, that are possibly involved in this conflict. He can now subscribe to this stream containing the conflict events, and he gets notified of every conflict that's actually occurred during this replication process. Come on, that's pretty cool, right? Item by item, he knows whether they're okay or not because he would be getting a conflict otherwise. From his perspective, he can now, listening to this conflict, come in and take some action if he believes that there was a problem here. How often do you think these occur? Is this something we're getting 100,000 of these a day?
All the time.
All the time. You'd be surprised it's very rare. If we are talking about less than 500 milliseconds, we would have needed 2 users in 2 distinct geographic locations to have made changes to the same things in the same 500 milliseconds. Don't get me wrong, it happens, but it's rare. We have now detected that this problem has occurred. We have made a marker that this problem has occurred. I shouldn't say problem because we don't know if it's a problem or not. It might be a problem. Somebody can actually look at this now, or some automation can possibly look at this now. It's been detected. The biggest problems that you run into are things that are not able to be detected automatically. Once I can detect something automatically and say, here is the situation that needs to be dealt with, this is the vast majority of solving the problem. How many of you have had a problem where you couldn't actually automatically detect it? Once I know that this conflict exists, at the least I can tell people about it. By the way, when you're looking at this, these two might be switched on you. For the vast majority of cases, that's good enough. I don't need to do any automation on top of it. So long as I tell them. He in 2 different geographic locations had did this without seeing each other's changes. There might be something interesting here. If these happen very rarely, it's no problem. But in terms of dealing with this, we're still well underneath 1,000 lines of code. It's not hard. This is not some fancy computer science problem we need a 10,000 line of code solution to, or we can geographically distribute this quite easily. And the only thing that we need to look at is that conflict detected. Once I have that, you can, by problem, analyze things and determine whether or not you want to go further. The key is coming in and being able to detect that this conflict has happened. Once I have this written down to this stream, we can have the subscriber come through, and they can run specific logic on this. Is an ATM transaction here and an ATM transaction here in conflict with each other? No. One of them might have overdrawn the account, not knowing that the other one existed, but they don't conflict with each other. Now, this might seem like we're getting into a bit of complexity, because we're allowing things to write without having necessarily known what other people have written. Keep in mind what we gain from this. We've gained the ability to geographically distribute, and we've gained the ability to guarantee our availability. Seriously, how many of you would like to guarantee your availability? How many of you would be willing to trade off quite a bit to do that? Here, there is possibilities that things are happening without having seen the other one. When I get these things later, I am capable of recognizing that this has occurred. These situations should be rare, and it's going to allow me to guarantee availability for people. These are strategies that you should be looking at inside of an event source system today. Now, everything we've been talking about so far has to do with servers, but all of this has to do with clients as well, doesn't it? What if I have a whole bunch of users on iPhone apps and things that are going through tunnels? This allows them to keep working. This overall strategy applies not only to little devices and things, but also to your servers. It works on both. And what's cool about it is that if you're already event sourced, this is not hard to build. Again, the only thing that we're using here is our version numbers associated with our events. We're allowing things to occur, and then we're only comparing the version numbers of the events between our multiple servers on that stream. Nothing more. Literally, you can implement a basic version of this in less than like 100 lines of code. I'm guessing probably even like 20. But keep in mind that what we get out of this is our guarantee of availability. We have dropped consistency, but we've now guaranteed our availability. Where we can get into more fun with this is when it's not 2 servers. Could I do this with 50 servers? Do all of my servers have all of the data? We could, example, have a partition per tenant that this was occurring on, as opposed to dealing with, say, a single stream or dealing with all. That selection is just another selection off of the events. It basically creates a stream. We can do this process to any conceptual stream that we can build up. By the way, I don't know if people have ever tried doing stuff like this before. The thing you have to be very careful about there is the definition of the stream changing over time. It was all streams that started with the letter S. Now it's all streams that start with the letter S and the letter T. And oh my God, I have to go backwards in time, don't I? But I can always find my issue here only using these 2 numbers that are coming through. I now will raise my conflict detected. On my side, somebody else can subscribe to this conflict detected, and they can take any possible actions that may need to be taken because this conflict has actually occurred. Now, could I guarantee that no conflicts will ever happen? Sure. But there may also be cases now where I'm failing a transaction because I can't guarantee it. Which do you prefer? Most systems will prefer this once they're geographically distributed. It's allow things to happen and detect the conflicts afterwards. Nothing here is very difficult. I can automatically find these conflicts. I can notify somebody of these conflicts, and hopefully they will resolve these conflicts. Well, we do have one problem in that we have no way of proving they actually resolved it, because I don't know if it's actually a conflict. We can get to the point of proving it, but then we have to actually add something for this was not a conflict. I have looked at this and determined that this is not a conflict, therefore I am saying it's not a conflict, so you can mark it as being done. Most systems you don't want to do this to. But what we're gaining from this, again, it's a simple code base. We are getting to the point that we can guarantee our availability. And I cannot stress to you enough how valuable that is if you're in a system that requires it. Most people associate event source systems in terms of CAP theorem as being consistent. They do not need to be. We can handle all of these scenarios where we're taking in events after the fact we are eventually consistent. We can do conflict detection. Git is a good proof of this. And when we start talking about Git, we also get down the other interesting part of the log. We might want to actually look at the concept of branches if we go further into this. Especially with offline devices, I might want to be able to say, I am starting branch Greg, doing a bunch of stuff on it, and then attempting to come back up. What would be involved with implementing that? My branch would just be another stream appending events to now. And then when I say I want to read, I read the original stream and then read off the new stream, which is the branch. That's it. How many of you think this would take more than a day to implement? But what benefits would that give to users who are actually using this type of system? There's lots of these kinds of things that we can gain. And it's always been funny for me that there's lots of people out there building these kind of geographically distributed systems, but very rarely will you see them event sourced. They're almost always SQL databases spread around. If we event source these types of systems, it actually makes things a hell of a lot easier, not more difficult. And the reason the problem becomes easier is because there's no concept of an update. We only have appends. Appends are much easier to deal with than updates of data are. Now, one question I get a lot, when should you start doing this? No, you probably don't want to build your system from the start with this unless you know for a fact that you're going to be geographically distributed later. Converting an existing system to operate in this way should not be a large undertaking. To be fair, how many new ideas have I put in around event sourcing in order to support this? What, that we keep 2 version numbers instead of 1? This isn't like a giant leap in terms of technology or you need a new framework for this. We want to delay this decision as much as possible if we can. If I can stick in a consistent system, I should. Converting that consistent system to something that can do this is a small project. Hopefully. This part of it won't be the big part of the project. It'll be everything else that's the big part of the project. But this ability to geographically distribute can be quite large for event source systems. The main thing that you need to remember is the trade-offs that we've been looking at. Understand that you no longer will have consistency. You will have variations in your logs. Understand that you can detect and you can handle these things. And your focus should be on making sure they are rare. What you want to avoid is getting 5,000 of these at the same time. Generally speaking, the easiest way of limiting that is to only allow systems to work offline for a period of time. If I've been offline for an hour, I should probably start considering maybe this isn't the best idea anymore. Now, generally speaking, you will not automate this. You will have a human come up and say, no more. But as that time grows, remember there are more and more and more conflicts that will be occurring. Every one of those conflicts has a cost associated with it. You can automate much of this conflict resolution, but you probably don't want to. It's low value stuff until you have 5,000 conflicts. Then suddenly it becomes high value. But we can distribute in this way. And if you're looking at building out event source systems and need to geographically distribute, this is probably how you're going to do it. Now, along with this, there's one thing that you probably want to add to your geographically distributed system, and that would be the correlation and causation ID pattern, just so that you can see how things are interacting across the different geographic boundaries. Okay. Does anyone have any questions? So the conflict detection is basically as I am following this node, right? I'm reading from his log and I'm sending over to you. I am including what that version number is here when I send it over to you, so that way you can check whether or not it would be the same for you. If they are different from each other, that's when we can identify that we have a conflict. Does that make sense? So I can't check it on this side. Only you can check it on your side.
How many nodes do you usually have in a system like this? And do you use vectors for numbering them instead of just two numbers?
How many nodes should we have? Yeah. It would depend completely on what we wanted to deploy.
So, like, let's take your biggest customer, for instance. How many nodes do they have?
The largest one I've been dealing with is probably about 500. But they are not large bits of data on each one. I guess I could take another one. They're probably about 10,000, but they're relatively small amounts of data per, and they tend to be aggregated up into groups. So it's still that many partitions that we're dealing with, but not that many nodes, if that makes sense. You can easily get this up into thousands. It's not that much of a problem. Beyond that, there's probably going to be some other things that you want to do. Resolving the conflicts requires business knowledge about what the conflicts are. No? There is no automated way I can do this for you. I can automatically detect that we have a conflict, but in terms of resolution, this is going to need somebody to look at it. Now, when I say somebody here, there will be a large number of these that are actually purely mechanical and you can write code for. If it's this and this is how we do it. Other cases, in particular where money is involved, will tend to have to go to a human being. Very often, if I've made a mistake with your money, I don't want something automatic to occur because it could turn out poorly. And people tend to get picky about those things when money is involved. Again, if we're having this happen even once a day, we're not talking about a large problem here that we are actually going to call someone on the phone for this. Our goal is to minimize the probability of these things occurring, automate the trivial ones, and detect the others. Does that make sense? And to be fair, I think you'll find this in pretty much every industry where there's a lot of these kinds of things I do not want to automate. One thing I've used in companies before is if this is a transaction value over $1,000, then always a human should look at it. To be fair, if you screw it up and it's going to cost you $1,000, you probably are willing to spend the $1 for someone to look at it. Even if 999 times in a row they looked at it and it was fine.
It is possible, isn't it, for two nodes to have logs that are the same length, but nevertheless to be in conflict if the last operation is different on the two
Correct.
nodes. And in that case, another operation could be deployed to both nodes. It could be interpreted in different states, but yet it would have the same index. So is there a risk that if there's already a conflict underway, that you fail to detect a conflict of that sort?
No, because I am maintaining your sequence and you are maintaining my sequence that you have read to. So you're ignoring what you actually locally have. You're pulling from me, and I'm pulling from you. I didn't see the mic there. Because of this, and because it's incrementing in this way, we will actually be fine. And you're basically just remembering your checkpoint on my data, and I'm remembering my checkpoint on your data. So it doesn't matter what I have locally. Does that make sense? Imagine we have two files that are logs, and they're pending logs. I remember what checkpoint I have read on that file, and I'm continually going forward on it. It doesn't matter what I have locally, I only have that checkpoint. Where things can get a bit of fun is if, since we're doing this back and forth, we can, under some circumstances, end up in fun things if we have other forms of automation that are occurring on top, where I get something from you, which causes something on me to actually write, which gives something to you, which causes something on you to write, which comes back to me, which causes something to write, which goes back to you, which causes something to write, and we end up in a ping pong going back and forth. To be fair, you'll normally recognize these are happening relatively quickly. Why do we write like 8.7 million of these messages yesterday? And by the way, this has been running like every 300 milliseconds over here. Any other questions?
What happens if you extend this to say... It's on there? Yeah, right. What happens if you extend this to say like 4 or 5 writers, and then you start getting conflicts?
Actually, it doesn't change, because each one is represented by on their own checkpoint. So if I have 5 servers, each of my 5 servers has its own checkpoint. So whether we're dealing with 2 or whether we're dealing with 3, it just changes the number of checkpoints, nothing more. So if I'm listening to 2 servers, then I have a checkpoint for each of them. If it's 5, then I have a checkpoint for each of them. The same mechanism works with n servers up, well, we'll say n servers up to, say, 50 to 100. Once you're getting past that, obviously, you want to look at a different model of this. As an example, we'd start benefiting from doing things like groupings. So these 20 nodes all put to 1, and then I talk to the 1 to get from the 20, as opposed to talking to each of the 20 individually. So we'd want to get into some form of clustering. Any other questions?
What happens if you can detect the conflict but you're not able to correct it after the fact?
There are many cases where I cannot automatically correct something.
I mean, not at all. Sorry, I mean not correct it at all after the fact.
There are some cases I might not even be able to correct that this thing ever occurred, in which case it's become a business cost. There are some operations that we might even want to escalate and say that this is not possible to do with. An example of this might be, for legal reasons, I am not allowed to have 2 of these things occur at the same time. So in order to enter into that, we may actually have a lock server over there that you need to talk to the lock server to enter on the beginning. But this would be an exception. I am escalating in this case. By default, everything works like this. When I need it, I can escalate the level. Does that make sense? Most systems say, we need to do this one operation, so we're going to support it for all operations, which is kind of backwards thinking. Any other questions? No? Okay, well, thank you guys for coming out, and hope you had a good time. Maybe see you around a bit this evening.